I'm Andreas Hamberger, and this is the Hamberger Report, where I cover AI governance, enterprise architecture, and the technology decisions that actually matter to the people who have to make them. If you find this useful, subscribe and hit the like button. It helps more professionals find the channel. Now let's get into it. The phone rang at 6 in the morning on February 19th, 1998. The voice on the other end was not interested in pleasantries. The power is down for the entire Auckland CBD. The entire country has no internet. I was Technical Services Manager at ICONZ, New Zealand's first commercial ISP. We ran on Linux, Red Hat Kernel 2.0 series. We handled email and DNS for government departments that had come to depend on us, the way you depend on infrastructure you have never had to think about. Which it turned out is exactly what we were. I'm Andreas Hamberger. This is the Hamberger Report, where I cover the untold history of the operating system that runs the world. Mercury Energy supplied the entire Auckland Central Business District through 4 110 kilovolt underground cables. 4 cables for New Zealand's largest city. Their own engineers had flagged the cable's condition for years. A consultant's report in 1993 had recommended replacement. Longer placement, the earliest for that placement, here February 19th, 3 of the 4 had already failed. The entire CBD was surviving on a single remaining cable. A colleague knew someone in Whangarei with a generator, not a rack-mounted UPS, not a managed diesel backup unit from a data center supplier, but a generator. In Whangarei, roughly 160 kilometers north of Auckland. He got in his car and drove there. While he was gone, we assessed our systems. The Linux architecture made this straightforward, in a way I had not fully anticipated before that morning. Configurations were text files, the startup sequence, the dependencies, the order of operations, all of it was documented and understood. When the generator arrived, there was no uncertainty about what to do. By lunchtime on February 19th, ICONZ was back online. When the 4th cable failed on February 20th, every other ISP in Auckland was still dark. We were the only ISP in New Zealand operating, running on a diesel generator sourced from a personal contact 160 kilometers away. That was Linux in production, and this is Act 2 of its history. There is a question worth pausing on. What exactly did Linux contribute to this story? The short answer is that Linux did not save us. Our colleague and his car did. The longer answer is more instructive. Linux contributed in 2 ways that only became clear in retrospect. First, operational clarity. Our systems ran on commodity hardware, configured in text files, managed by a small team who understood every layer of the stack. When power was restored, there was no proprietary configuration locked inside a system we could not examine. We brought everything up the same way we always had, because we understood it completely. No vendor documentation required. No support contract standing between us and our own infrastructure. Second, the culture of the people who ran Linux in 1998. The colleague who drove to Whangarei was not following a run book. There was no run book for this. He was following a culture that said, the problem is in front of you, the resources available are what they are, the same culture that produced the kernel itself, distributed responsibility, bias toward action, no waiting for permission from someone upstream. The contrast with Mercury Energy tells the other side of this story. Their engineers had flagged the cable's condition since 1993. The institutional knowledge of how much load those cables could tolerate had walked out the door with the redundancies that followed the electricity reforms of 1992. What remained was a maintenance regime that trusted historical performance over actual condition assessment. Every architecture review I have run since has produced at least one version of this problem. A known dependency, a flagged risk, a deferral decision that looks rational in a spreadsheet and catastrophic in production. By the time the recovery cost Mercury Energy an estimated NZ $150 million in direct costs, a government inquiry, and the loss of its CEO, the proactive replacement of those cables would have cost a fraction of that. In 2026, we call the testing side of this chaos engineering, deliberately inducing failure to verify that recovery paths actually work, before the production incident forces the test. The principle is identical to what my colleague did when he drove north. Find your single points of failure before a crisis does. Late 2000, I was at Telecom Extra, leading a team in a world built on Windows and Solaris. Linux existed in pockets, running things the enterprise stack could not quite manage, but it was peripheral. The serious infrastructure was proprietary. This was a very different environment from ICONZ, where Linux had run everything. A year earlier, on the 11th of August 1999, something significant had happened. Red Hat went public at $14 a share. By end of day, it closed at just over $52, a 227% first day gain, the 8th biggest single session opening in Wall Street history to that point. Run enterprise IT directors managing mission-critical infrastructure. This meant something specific: permission. Wall Street had told the C-suite that free software could be a serious business. The model Red Hat proposed was straightforward. The software was free. The support contract, the enterprise SLA, the certified patch management, those cost money. You were not buying software, you were buying certainty. Then, in December 2000, IBM CEO Lou Gerstner announced at an industry conference in New York that IBM had already invested approximately $1 billion in Linux, with more committed for 2001. I printed the news and walked into my manager's office. Sooner or later, I told him, I am going to leave Extra and dedicate myself to Linux. He laughed, a kind laugh. Stick to your guns, he said. He meant it as caution. I heard it as confirmation. The Red Hat IPO had told Wall Street that open source was commercially serious. IBM's announcement told the people who actually ran enterprise IT that the world's largest technology services company was betting $1 billion on Linux as the future of the data center. Those are two different audiences. IBM was speaking to the second one. The objection to Linux I had encountered most often was never technical. It was support. Who do we call? Red Hat had addressed this with support contracts. IBM amplified it by standing behind the platform, with the company reporting annual revenues of approximately $80 billion US dollars. IBM's motivation was not altruism, it was architecture. The company that had lost the personal computer market to Microsoft had learned an expensive lesson about controlling the software stack. By embracing Linux, IBM could commoditize the operating system layer and compete on what it was genuinely better at: hardware, services, and enterprise integration. The OS would be free. The Power System server, the global services engagement, the mainframe migration, those would not be. IBM ported Linux to its Z-series mainframes in 2000. These were machines that had run enterprise workloads for decades, underpinning financial systems, government databases, and insurance ledgers across the world. Running Linux on a Z-series was not a technical experiment. It was a statement of intent. If Linux could run on a Z-series, it could run anywhere. Senior Vice President Bill Zeitler later reported that IBM had recouped most of the first billion in year one through sales of software and systems. By 2003, IBM's Linux-related revenue was estimated at approximately $2 billion US dollars annually. The ROI argument was settled faster than almost anyone had predicted. My first encounter with Red Hat Enterprise Linux as a formal procurement line item came when I worked on the IBM delivery of Air New Zealand's online ticketing platform. By that point, RHEL was not a position anyone needed to argue for. It appeared on a project budget alongside the network infrastructure and the load balancers, evaluated against support SLAs and hardware certification matrices. The airline's online booking system needed availability at a level that the Linux of 1994 could never have been expected to guarantee. RHEL provided that. The market had signaled what it needed. Red Hat had built it, IBM had validated it, and New Zealand's national carrier was running its ticketing infrastructure on it. That was the quiet completion of a loop that had opened when a 22-year-old Finn posted to comp.os.minix in August 1991. IBM's strategic logic in 2001 was deliberate. Make the operating system free. Compete on everything above it. The OS was the commodity. The hardware, the services, the enterprise agreements, those were the margin. Commoditize the foundation, extract value from the layers above it. Today's AI hyperscalers are running the inverse. The infrastructure is largely open. GPU clusters are declining in cost, training pipelines are increasingly understood, and the Linux systems underpinning every major AI workload are free. What they are pricing as proprietary is the model, the weights, the fine-tuning, the safety alignment, the API access. The model is the new operating system. They are trying to be the new Microsoft. DeepSeek disrupted that logic in early 2025 by releasing model weights openly. The cost structures that had justified proprietary model pricing collapsed almost overnight, reprising IBM's move at compressed timescale. The same open platform economics IBM demonstrated in 1990. The structural disruptor of vendor lock-in at the foundation layer. The question IBM forced on enterprise IT in 2001 is the question AI is forcing on organizations in 2026. Do you own your foundation or does your vendor? If you cannot inspect the system you depend on, you have not built infrastructure. You have acquired a dependency. Two threads run through both stories in this episode. The first, resilience, is not a feature you add after the crisis. It is an architectural decision you make before it. The colleague who drove to Whangarei understood that instinctively. The cables that were never replaced until they failed did not. The second, you control your tool chain or someone else controls you. IBM understood this when it gave away the OS in 2001. The risk in 2000 was never Linux. The risk was dependency. Long manager's caution was kind and well-intentioned. It was aimed at the wrong thing. If you enjoyed this episode, subscribe. New episodes in the History of Linux series every week. Unsubscribe to the Hamberger Report. New videos every day. That is the Hamberger Report for today. If this was useful, subscribe and hit the like button. It helps more professionals find the channel. You will find links to everything we covered in the description below. I am Andreas Hamberger, and I will see you tomorrow.
Wow.